start कर लीजिए. Got it.
Okay, let's start. Yeah.
Okay, so welcome to Bash shell. And earlier the first shell was actually where is it? There was a sh, then there was csh, which is C shell, and then there was tcsh, turbo C shell. So, and the bash is the latest, and it's the most modern shell derived from Bourne shell. All right. And Linux, it is default. It is sort of superset of original shell, and a lot of commands it was there. So it's evolution. It's evolution. So it includes shell and C shell. All right.
Yeah.
So in shell, to execute commands in the live file.sh is required, file.sh, but bash allows source file.sh. So there you just run file.sh, give it the executable permission plus X, and run it. And bash allows source file.sh. In bash, you source it. Okay. And I think last time talked about it, that bash allowed no aliases. Alias means you can change the name of a large command to a more comfortable command. Okay, you have to define functions. Bash includes the alias command. So an example of alias, so you can say alias rm minus I as rm. Okay, what this means is that interactive remove will be the default remove. Remove will not behave as just rm as organized in Linux. It will behave in interactive fashion. Similarly, you can change the nature of any command by doing aliasing. Aliasing means urf, just a different name. Okay.
Right.
Now, how do you configure the bash shell? So there are quite a few files where you can make it customized to your thing. One is this etc. profile, global system configuration for all users, controls, environmental variables, and programs to be run when logging in. Then there is a bash RC, which is the global system configuration for all users, sets of aliases, global aliases, and functions, okay, which can be used in daily routine. Okay. All right. Then there is a local version also, which users customize. So there is two levels of customization. One is a global one is the user level, and .bash profile, local system configuration for a specific user, controls environmental variables and programs to be run when starting a bash shell. .bash rc, local system configuration for a specific user, sets up aliases and functions executed after bash rc. Okay. And you can set the value of display, printer, pager, etc., etc. Path is very important. That is how it sort of kind of finds out binaries. Okay. So if you're looking for a program you're running, it will search on all those paths. And the way is name value or export name, export value, like that. So here is a sample profile. You can see path. Path is given, then export path, and erase character is control H, and your cursor is going to behave host name with login, whoever has logged in, and then you can have SSH and umask extra. So like it is saying, set the path variable and export it. Path will be set to that, right? Set the backspace key to delete the preceding character. Set the prompt to include the name of the host machine, and whoever has logged in, and define a function stack2 to log in in SSH. Alternatively, you can also see the use of alias. Okay, so that function is no need to define the function. You can just do alias. Okay. Set the default permissions on files. That is the uname thing. umask 077. Now, how do you control the job? It is very important to manage this. To put a job in the background, terminate the command with ampersand. So you want to start, let's say Firefox, you say Firefox ampersand. Now it will make your cursor available, and it will run in background without, you can run other jobs on the cursor. Okay. If a job is running on the cursor, you can stop it using Control J. It's like suspend a job. To put the job into the background, use BG. To put the job into the foreground, use FG. And to see the jobs running in the background, jobs. And here is how you kill the jobs.
Sir, when we
Yes.
when we want to kill this any job we are running or this, we use kill space this dash and 9 space this percentage and name.
No, percentage and nine. When you do jobs, every job has a PID, process ID. Okay, like Firefox will have a process ID. Like you are running a text editor, it will have a process ID. And every program is very systematic operating system, right? So unfortunately, I am not on Linux. Otherwise, I would have shown a demo. So when you type ps-u, let's say my login name is P-Ranjan. So it will show all the processes running on the system. Okay. And then let's say I have to kill Firefox. So I find the Firefox process ID, and then I do kill -9, whatever the process ID is.
Okay.
Okay. So it's very, very systematic. Everything is accounted, well organized, audited, and you will be able to see nothing without my control can run.
Okay.
Every application is a process, which is the right way to think about it, because they're a time variable, not program. See, typically computer scientists call it program. That's a wrong use, because time is involved. It's a process. It evolves with time. The whatever code is written, it actually has a time axis, which is very, very useful. So Unix calls it process, not program. Program means it's a static. There is no time component, but that's not true. Firefox runs in time also. You look at memory utilization, you look at bandwidth utilization, you look how it behaves, efficiency, all that. That has a time axis. I hope that's becoming clear.
Yes, sir.
So you just do kill -9, kill space -9 or PID of Firefox or whatever else you have. Okay. So it's very systematic and very right way to administer a system. You like it, very, very organized. Then there's a history command. So you can, what you can do is that you can do last NN command. So you want to just repeat last command. So that is double exclamation. Okay. If you do history NN, then it will do, like, let's say NN is 10. So it will do the 10th last command. Okay. And if you do exclamation and string, it repeats latest command starting with string. Okay. So history is very useful. If you are repeating a command, it's very useful. If you do just double exclamation, it will do the last command. And then if you do history 10, it will do 10th last. Or you can do exclamation with strings like who. So it will just type who. Okay. So a lot of very useful hacks are there. Slowly as you learn, you'll be very happy. Now here are some more interesting things. So output redirection to a file. What this means is that my data is spitting some output and I'm sending to a file. Similarly, input direction from a file. What that means is that my program will take input data from a file. Piping. Piping means running two programs at the same time. So I can say that, let's say cat, some file names, and this is pipe. Okay, WC means count the character. So it can say, depending on how many characters are there in names file, maybe say 35. Or I can say WC minus L. So it will count a number of lines like 5.
Okay.
Okay. So
Yes.
piping is very, and you can do 2-3 pipes. Output redirection, the way it works is that ./a.out, and I can say output. So what will happen is that output of the program will be written in the file output. Input is, so you can do cat input a.out like that. You can have 3 layers also, cat input, which is going to a.out, and this can go to output. So you can make very interesting recipes out of this. It's a very exciting program. Okay. Now, what is standard input? Standard input is keyboard. Okay. Or it could be a file or a command. Standard output is your monitor. Okay. See, in Unix, everything is file. So keyboard is also a file. It's an input file. Your monitor is also a file. It's output file. Okay. And a standard error output. This also goes to monitor only. Okay. So if you don't do this output redirection, it will appear on your monitor. If you don't do this, it will appear on your monitor, or it will return to file output. Okay.
Yes.
So it's very interesting what all you can do. So how much do you want to continue with?
Yeah, we can stop
one more
here.
slide, maybe one more slide.
Yeah, if you can please.
Okay. So here it is shown in action. Same thing. You can see command can be a.out, just to show you the executable. Here is append. Append meaning it will paste it at the bottom. Okay. So I can say cat names and append at some file name 1. Okay. So this will be at the bottom.
Okay.
Similarly, input direction from the file, you can see this is the command input and this is pipe. So like I showed you, I can have who WC minus L.
Okay.
So should we take a break here?
Yeah, we can stop here. So what command we have discussed today? We can summarize.
So we discussed a lot of redirection. We discussed history. So we can go back. A lot of file redirection is very important, input output. Okay. Yeah. Then we discuss history. Okay. Then we discuss how to manage jobs. Okay. This is very important from automated management of systems perspective. Even if you do cloud, this will be useful. Okay. Then we talked about how to generate your dot profile file, how to customize your environment.
Right.
Okay. And then we talked about it, bash shell. Okay, bash shell, how the customization happens.
Right.
Okay.
Right.
And then alias.
Yeah.
And the bash shell. So we talked bash shell, history, customization, input output redirection. 4 or 5 topics are there.
Okay, sir. We can stop here then. Okay.
All right.
Stopping the recording.